this moment I want to share you regarding about force and motion. Yes, I have five numbers about question in force and motion. Yeah, and I try to solve this question. Actually, I already solved this question. Yeah, and we try to prove the answer because answer is already prove it. Yes, like this one. Number one, yeah. Oh yeah. Before we continue, please don't forget to subscribe my YouTube channel. Yeah. Number one, a man pushed a car with a force of 127.5 Newton along a straight horizontal road. He managed to increase the speed of the car from 1 meter second minus 1 to 2.8 meter second minus 1 in 12 seconds. Yeah. Find the mass of the car. Yes, the answer is 850 kilogram. We need to provide it. We need to prove. Yeah, into the answer. The answer is 850 kilogram. So actually, we have two formula here as the Newton's second law as force equals to mass time acceleration. And then we have the acceleration here. So 1 meter second minus 1 is the initial velocity and 2.8 meter second minus 1 is final velocity and 12 second is time. So actually 2.8 minus 1 divided by 12 is acceleration, right? Okay, let me see about the answer is. Okay, try, yes. Nah, the one. We use the formula of Newton's second law that force equals to ma, yeah, mass times a, yeah, mass time acceleration. And so yes, m equals to f divided by a, right? Yes, here. Yes, and a actually what I mentioned before, a equals to v minus u divided by t. So we get u is 2.8 minus 1 divided by 12, or 1.8 divided by 12. Yes, this is equals to 0.15 meter second minus 2. Yes, this is the acceleration. So we can substitute this number onto here. So mass equals to F divided by A. Let me see about others. Yes, the one. Yeah, the force equals to 100 to 27.5 divided by 0.15 equals to 850 kilograms. Yay, we finally get the answer for number one. Continue to number two. Okay, we have the question here. You can see first. Okay, the question is, I give you a few minutes, 2 minutes to write this question. Okay, a runaway sled of mass 10 kilogram traveling at 15 meter second minus 1 reached a horizontal snowfield. It travels in a straight line before it comes to rest. Given the force of friction slowing the sledge down has magnitude 60 Newton. Calculate how far the sledge travels in the snowfield. Okay, the answer is 18.75. Okay, we know about mass here, 10 kilogram. We have the initial velocity 15 meter second minus 1, and travel straight line before come to rest. Rest is the final velocity equals to 0, and frictional slowing down has magnet. This is the frictional force, yeah, 60 Newton. Okay, how to solve this? But before we continue, we know about Newton first law, F equals to ma. We have mass, we have force. So we get what? We get acceleration. But this is about deceleration. Why? Because come to rest. From the start velocity is number something, and then come to zero. This is about deceleration. So we see the question, we see the answer. Two. Yes, A means force divided by m. 60 divided by 10 equals to 6 meters seconds minus 2. Okay, after we get the acceleration, actually this is deceleration, yeah. After we get the number of deceleration, we continue to find how far, yeah, let's travel in the snow field. We see here, oh, where is it? Oh, here, oh, here. Let's we see. Down. Okay. With the formula of v square equals to u square plus 2as. This is actually about linear motion, right? Yes, u as the 0 and initial velocity is 15 square and plus 2a as the deceleration what I think what I get before, yeah, 6, but in minus because this is deceleration, right? Okay, we finally as actually this is 15 square is 225, yeah, divided by 12. You see here how much is it? Oh, yay, we get actually 225 divided by 12 is 18.75 meter. Okay, if you want to copy first, yes, just copy and let, if you want to see again, and I continue to number 3. Okay, here, please read it. I give you a moment, I give you a few minutes to read it, but don't forget to subscribe. Please subscribe my YouTube channel. Okay, number 3, a boy pushing horizontally a box of old newspaper of mass 8 kg along a straight path against a frictional force of 16 Newton. Whoa. Calculate the force with which the boy is pushing when he is moving. To condition A, with constant speed, the answer is 16. And B, with constant acceleration of 1.2 meter second minus 2, the answer is 25.6 Newton. Okay, how to solve this? I give you a moment to solve this question or to hard thinking about this question. Okay, I want to see about how to solve this question. For A, this is actually for A. Yep, done. Yes, at the constant speed, yeah, total force equals to 0. Why? There is no acceleration, there is no deceleration. It's constant speed. There is no increase in velocity or decrease in velocity. So there is no acceleration. Or we can say total force equal to 0 or force minus frictional force equal to 0. Then 16 is frictional force. So we can say the force equals to 16 as the same thing with frictional force. Okay, how about B? With the constant acceleration of 1.2 meter second minus 2. Ta-da! We see the answer of B. Yes, yes. If they have acceleration, so the formula is not same with the before, yeah. So force minus frictional force equals to mass times A. So if we substitute these numbers, yeah, force minus 16, 16 is frictional force, equals to 8, it is mass, and 1.2 is acceleration. So yes, we move, yes, 16 move to the other side, move to the right side, so minus to become positive, minus become plus, or negative become positive, yeah. 16 plus 8 times 1.2 is 6.9. So we can, the number is 25.6 forget Newton. Okay. Okay, you can see this number if you want to copy. Yeah. And I try to scroll up the number of 4. I give you a moment to read this question. 2 minutes. Mm, mm. Yep. Number 4. A railway engine mass 5,000 kilograms is moving at 0.25 meter second minus 1 when it strike the buffer is sliding in a siding. Given that engine is brought to rest in zero point 0.4 second, find the force assume constant exerted on the engine by buffers. Okay, we know about the acceleration. This is actually so easy. Only use the formula of F equals to m times A. M is 5,000 kilogram and A is blah blah blah. Okay, we see the answer here. Oh, sorry. Where? Oh my god, where is the answer? Oh, here. Ding 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 ding. Ta-da! Yes. The first one is we find the acceleration is actually this is not acceleration, deceleration, right? Because brought to rest, yeah. Start from 0.25 meter second, broke to rest. Yes, rest as the zero velocity or 0 minus 0.25 divided by 0.4. After we calculated blah 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 blah, we get minus 0.625 meter second minus 2. This is about deceleration. Okay, come back again to Newton's second law that F equals to ma. Yeah, m as the 5,000 times 0.625. Yes, we get 3,125 Newton. Okay, done for number 4. I will holding it and I will see the number 5. Yeah. Oops. I give you a moment to read or copy. Copy for number 4, read for number 5. 2 minutes. Okay, number five. On a particular journey, the resistance to motion of a car of mass 1000 kilogram, yeah, this is kilogram, is proportional to its speed. The car traveling at constant speed of 15 meter second minus 1 with driving force 870 Newton. The driving force is instantaneously increases to 1200 Newton. We have two questions. Question A, find the instantaneously acceleration produced. The answer is 0.33 meter second minus 2. The B question, find the resistance to motion and the acceleration when the car is moving at 20 meters second minus 1. The answer is for the force is 1160 Newton and the acceleration is 0.04 meter second minus 2. Okay, let me continue about this solving question is. I give you a moment to just thinking about this question. Yeah, please. Okay, done. I already provide the answer for A and B, but in the color white. I want to show you in the color red. Yeah. I repeat again. Yeah, this is mass is 1000 kilogram. In the speed 15 meter second, driving force 870 Newton and instantaneously increase it into 1200 Newton. Find the instantaneous acceleration produced. Okay, we see where is the answer is. Oh, oh, yes, here. Ta-da! Yeah. Go to here, 0.33 meter second. Same thing with this one, right? Okay, now why? Yes, this is the total force equals to ma. Force as the force of driving force, yeah, minus resisting force equals to ma. Yes. At the constant speed, driving force, yeah, equals to resisting force, yeah. Yes. At the constant speed, 15 meter second, the resisting force equals to driving force here, yeah. So this is actually resisting force, yeah, 870 Newton. So we can substitute this number 1200 as the driving force minus resisting force is 870 Newton. So equals to mass times E. Mass is 1000 kilograms, yeah. So this is actually 330, right? Yes, 330, yeah. Divided 1000, yes, correct, 0.33 meter second minus 2. Yeah, finally we get the answer for the A. Actually, we already calculate this answer. Okay, continue. How to solve B question? I want to zoom out, yeah, because this is on the different page. Oh my god. Here. No, question B is find the resistance to motion and the acceleration when the car moving 20 meter second. Yes, actually they have your resistance motion at the 15 is 870. How about is 20? So we only ratio. Let me see. Oh my god. Oh, oh. So, yeah. Let us see. This is about ratio between velocity and the resisting force. Yeah, when the velocity 15, we have the resisting force is 870 Newton. So when 20 meter second minus 1, how much resisting force is? Yeah, just ratio between velocity equals to ratio of between resisting force. Yeah, so 20 divided by 15 equals to driving force for the resisting force for the collision 2 divided by 870. Yeah, so calculate this number, we get 1160 Newton. So, what about the acceleration? Yeah, come back to total force equals to 0. The total force as the driving force minus resisting force equals to ma. Yeah, driving force is 1200 and resisting force is the number here 1160 Newton equals to m as the 1000 kilogram times a. Yeah, we get that. This is 40 divided by 1000, 0.04 meter second minus 2. Okay, we finally get all the answer and the question is only 5. I hope this explanation can help you about the how about to get the information to solve all the in the question force and acceleration. Yeah, so and yes, the block here. Yeah, oh, thanks for watching my video. Don't forget to subscribe my YouTube channel, comment, please comment anything you want to comment, like, also share to the others. Thank you very much and see on in other videos.